Hello folks, well next one out of the box is a Rotel 220. Well, it's in a bit of a bag. I trust you're enjoying the new on the air test format. May not always be able to do that, but we will when we can. So we've got the factory original mic. I think the safest bet is to set it up on the test mic and then come to that later. No corrosion on that one either. Well, we don't have to test PA on this, it doesn't have it. Get it connected up to the test equipment. We'll do some figures. Some high-low power is inconveniently at the back, but I've just made sure it's in normal. We'll get the standard test mic. We've got a Cybernet power plug stub somewhere. There we go. Right, power supply on. We don't know anything about it, so we'll put it on 9 volts, 300 milliamps, just in case there's some kind of short circuit on its channel 11. Put it onto full power. It's drawing 200 milliamps. Now it's drawing 318 milliamps, and it's lit up how we'd expect. So have we got any bits left on our piece of paper? I'll go on the other side. So it's Rotel RVC220. We had one of these in a few months ago, and it's still here from, I think it's October, and it had a bad aerial on it. I won't begin to tell you how many sessions we've had on that set going through transmitter parts. So I think when I've done this one, after I've done this video and behind the scenes, I will make one final attempt at that, and they'll be getting it back fixed or not fixed. It kind of works, but it's not right. Can you understand it? It works, but it's not right. Tell you what, we'll just run through some tests. So a little bit of noise there on the volume control. 3 watts. Let's put that on the inset picture if we can find the right button. There we go. So full scale deflection, we're on the 3 watt scale. So that's what it is. Doesn't sound like it's been fiddled with. Is that steady though? Transmit frequency. We'd expect it to be a bit on the low side because of the age of the set, and it is 2779043 is, I understand it, beyond what's legal. So it's 2779043. The test set's been on some time, so that we know that's warmed up. Whilst I've got that in mind, I'll set the signal generator to exactly the same frequency, so that when we come to test the receiver, we're giving it a fair test, because of course that will be our frequency exactly the same amount. So that's us now in the signal generator. So we'll go to deviation, Wallow. 1.5 kilohertz deviation. And let's have a look at the what we can get on the cyanide. So it's a respectable 0.75 microvolts for 12 dB cyanide. And that's in spec as it is, so that's fine. Okay, we'll run through this. To use the bigger screwdriver, they're in tight. I think I've seen a Comtron CB40F in this box. I think that's going to be another forthcoming attraction. Seemed to have a lot of those last year. They always worked well. I always tread carefully here because these wires can be shorter in some sets than others. And I've seen this tag ripped off speakers before now, and I've had to araldite it back on. So we'll just check if we can see anything that shouldn't be there. No, we can't see. It still smells newish, even if it's 40 years old. We'll start with the VCO, and we'll put the radio on channel 40. Because that's how it's set. Put that meter, that camera onto there. We'll borrow Mr. Chippy's the only other straggler we've got, apart from the Rotel 220 from 3 months ago, is the PE Ranger from a few months ago. I haven't forgotten about it. So we want 4 volts, and it's on receive. It's 4.5, which is a little bit high. This is important adjustment because if you don't get this right, you can find channels missing in temperature extremes. A bit like a normal Midland 78 plus multi like we have in the test car. We have to leave it on overnight in winter because it's that. Is the word crap? We've got 3 of them and they're all the same. And yet the previous model was fine, the amber one. Right, into transmit. It's 3.36, which is a bit low, so we'll just a trimmer for 4 volts. I think that'll do me. Let's go back to receive. That's fine. So on channel 1 we expect it to be between 1.8 and 2.3, something like that. So here on channel 1 receive 2.3, channel on transmit 2.28. Absolutely lovely. Now the important thing is to remember to put it back to channel 20 so that you're doing the tune up in the centre of the band. So we're at 3 watts. No improvement. No improvement. No improvement. So you've got to do this next bit quickly. You've also got to hope none are broken. Knights do sell these cores. I think they're 125 each or something. So whilst Knights are still around at Curtin and Lindsay, that is a source. And the only source I know of. So the idea is to peak these three. So we're now at 4.5 watts. Because the radio can't actually source this for long, could end up with smoke coming out of the PA. You've got to be quick. So this particular one has just gone to 5. I'm going to check them again. So this yellow one, once we've got the 3 as a peak on channel 20, it's this left hand one, L4, the yellow one, to 4.4 watts. There we are at 4.4 watts. And then it's the green one, anti-clockwise. Now they say in the service manual 3.8 watts, but as I say, they have to get these sets through customs. We do it to the legal limit of 4 watts. Not that it makes any difference to your range, but it might be that extra foot that you need, you never know. And now, having done that, we'll check on channel 1 that it's somewhere within 0.1 of 4 watts. We're about 3.95 on channel 1, and we're about 4.01 on channel 40, so that's balanced beautifully. Because you can end up with 2 watts at one end and 4.5 watts at the other end. You know, this is what can happen. So that's the balancing. So the meter needs to read 4 watts on the dummy load. Remember, when it's on an aerial, it may read anything. It might read 2, it might read bang across the scale. It doesn't mean you're doing more or less power. It's relative to SWR. So that was banging across saying 5 watts. It's now on the 4. Switch to low power. Should be 400 milliwatts. It isn't. It's 0.1 of a watt. It's 100 milliwatts. I'll just put some service on that preset. They can get dirty. I'll waggle it around. Sometimes you have to replace this. We're bang on the 400 milliwatts there. So go to this test set. It's 3 watts on the full scale deflection on this range. So we're on this scale. So there's the 5, there's the 4. So it's 400 milliwatts, 0.4 of a watt. If I switch it to the 30 watt scale, which we did the tune up on, put the radio back on 4 watts, and you'll see it's on the 4. We'll just pop the radio on frequency, hopefully it'll go. I could have done this at the start, it would have been more sensible, but it's not stupidly far out to be any effect on the tuning of the transmitter. There we go, spot on frequency, like I'm showing you. 2779125, just like it, that little bit high. 2779125 toggling 6, because these drop with age, and so does the quartz crystalline you watch and your colour television. So it's now 4 watts. It's now 2779125. Yep. And now we'll check deviation, which was 1.4. So I want the feedback, because you've got a deviation, you've got a kind of audio feedback thing, circuit. So I want that one, the vertical one, so it's dead in the centre. And then we'll use this one. They're a little black. They do tarnish it because they're silver plated in this radio. So look at this. If I get my fiberglass brush, Doesn't make any difference, but I'm just saying it's silver and it's tarnished. So you can imagine that the contact side also tarnishes, which is why you sometimes have to waggle them around even though they haven't worn or anything. Right, here goes. That's a bit low. Wallow. 1, 2, wallow. I'll just check my test set. Wallow. Check we're tuned in. Wallow. Go back to that. Wallow. 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 There we are. We're set up. Just check the factory original mic while we're at it. Wallow. A bit more gain with that. Wallow. So we just drop that a bit for that mic. That's the right mic. So, what else have we got to do? That's it, we've done the transmitter. Let's move on to receive. So now I need to set the signal generator for the correct frequency of 27.79125. Because remember we had it low, so we've got a fair reading of the radio which was off frequency at that point. There we go. So the first instrument we're going to look at is we put the oscilloscope on. There's nothing clever about this. It's just across the extension speaker terminals. I put a big signal on. I'm putting 100 microvolts on the signal generator, which is equivalent to S9 on a CB radio in the UK. And I need to just make sure that the detector or the demodulator, call it what you will, this coil here is recovered audio to its maximum. There was a tiny little difference there, but I don't think anybody would notice. So now we're going to go over to the Synad meter. I will just mention this Marconi test that I'm using does have a built-in Synad meter. We've got 3 of these Marconi 2951 test sets, and none of the Synad meters work on any of them. So either we don't understand how the Synad meter works, or they don't work, or you need an accessory or something, but they don't work. So this is why we have external Synad meters. This Motorola is an automatic Synad meter, and because this is the one we do the videos on, this is the one we have on this bench. The other benches with Synad meters are the Synadder ones. The bench we have with the Farnell TTS 520 and SSG 520 combination test set has a digital Synad meter in, which actually works, but it's actually easy to do it on one with a needle. Right, so we want to set this so the needle's about 4 dB. That's so we can, if we had it saturated up there, we wouldn't be able to see any adjustment. So we wanted to be able to see adjustment, and as we make adjustment and make improvements, we then attenuate the signal further with the signal generator's attenuator. Now you've got less receive circuits in this. You'd have an extra coil there if it was a base station, like the Harrier CBX or the Midland 76900 or the York 869. And if it's one of the bigger in the range sets, like the Rotel 240 binder tone 5-star, you've got an extra coil there. Some Harvard 420s have the extra one and some don't. It's a bit of a 50-50. So here we go. Are we going to get any improvement on the 0.75 microvolts that we already have? And the answer is yes. You know, I repeatedly touch that coil and get major improvements. I don't know what they were doing at the factory apart from tuning it to a line and then sending it on the conveyor belt. Just don't think they do what I do at these factories. They just tune them quickly. They're probably in 20 seconds. They get it to a line on a test instrument and off it goes. It's never peak. Well, that's impressive anyway. Now I'm going to put a bigger signal in so I can see the IF. Just going to recheck that one with a bigger signal. Slight improvement there. Drop the attenuator a bit. Okay, we're done. So what we're getting now, if I make sure the needle is on the 12 as near as damn it, I've now got 0.41 microvolts. So that's 2.2 to 2.5. That's the peak, that's the average. And we've now got 0.4, I'll say 0.42 microvolts. So we have got an improvement. Good. So we want to set the meter so that for people who like to know how many pounds they're pushing, should be S9 with 100 microvolts off the signal generator, and it is bang on S9, so it doesn't need adjustment. The adjustment for that is there. The factory got that one right, and it hasn't drifted over the 40 years. So the next one is the Squelch. So just going to turn the attenuator down on the test set. I'll show the attenuator controls. Turn the cyanide meter off in the oscilloscope and save some electricity. And we're going to put the Squelch on the radio to full. Now I want that Squelch to open when I hit 100 microvolts with the signal generator. 1, 3, 10, 30. It's coming in at 30. So this Squelch is actually too weak. So preset there. I've just adjusted it till the Squelch has come in. So back on with the attenuator. Opens at 100, just where I want it. That is adjusted. Now then, let's check the Squelch at the other end. So I've put the signal generator to 0.3 of a microvolt, and we now put the signal generator to standby, turn the Squelch down on the radio, set threshold, switch the signal generator back on. It's come straight in. So it's coming in at 0.3 microvolts, it's dropping off at 0.26 microvolts. As I always say, the Squelch isn't the best Squelch in the world on these sets, but it's competent and adequate. We're done. That's it. Another quick tune-up. So that's 3 sets from this customer, which have just needed a normal tune-up and have no faults. And no illegal modifications or silly modifications. So just before I plonk that on, we need to clean the volume control. Just turn the radio off and turn the power supply off. So just waggle that around a bit. Put the power supply back on. Yeah, that's perfect, it's gone in. Get the lid back. Put the lid on the right way. Notice there's some kind of fine chips at the edge. think that's where mice have been gnawing at it. Well, there would be if they were in this house. Surrounded on 3 sides by fields with woods on the other. So it's Saturday, it's about 11:15 in the morning. Just check the internal speaker works, it does. We're going to put this on the, I'll take it off the test set, we'll put it on the roof area, which I keep saying is an Antron 99 type. There are other brands of the same design. It's a single story building and it's mounted just above gutter height. So it's not the highest aerial in the world, and that's what we use for the tests. Right, here we go. One niner Roger. I think there's still a bit of a lift on. Right, that's where we'll leave it, and we'll do an on-the-air test later on. So thank you for watching the Rotel RVC220 Cybernet 134 chassis set from 1981.